So I'll bring some news from Europe about ROS-Industrial. And yeah, I think, I switched it. So, but first of all, I just wanted to shortly introduce to you Fraunhofer organization, so the organization that I'm part of. So Fraunhofer Society, or Gesellschaft in German, is the biggest research institution in Germany. We have about 30,000 employees, 76 institutes, and close to 3 billion euros of annual budget, coming from national funding, but also from contract research in Germany, so which means direct private contracts. And I'm from Fraunhofer IPA, which is the Institute for Production and Automation Technology. Basically, we are one of the biggest Fraunhofer institutes, I think in the biggest three actually, with a budget of 82 million per year, and you can see over 1,000 projects per year, above 1,000 employees, and yeah, so that's Fraunhofer. You see our nice location there. If you ever want to come there, just contact me. I'll invite you. We are basically active in all kinds of sectors. So from automotive, okay, we're based in Stuttgart. Yeah, a lot of automotive companies there, but also in electronics, energy, health industries, machinery, equipment, and processing industry. So that leads us to the question, why do we actually work with ROS, right? And that is because basically we do a lot of different applications in different sectors. And for us, ROS has always been an easy way to enter into robotics. And we had like a lot of success stories at Fraunhofer IPA with ROS. So all these applications that you see here, hope they are running, yeah. All these applications here that you see here are implemented based on ROS, and some of them are already in industry. So for example, navigation went into a spin-off. Cabling has been developed with a big cabling company from Germany as well. Assembly guys are also planning to spin off at some point. So a lot of things going on here, a lot of things also in cooperation with our partners in Southwest Research Institute about publishing, for example. And we've also been very successful with ROS and bringing ROS into industry. So for example, our department of roughly 70 researchers, in the last 5 years, we had 3 spin-offs, which is basically one record in Fraunhofer organization. And all of these are actually based on ROS. So you see Motion Robotics, which hopefully is running as well. Last one is not running, sorry. You see Motion Robotics, which is the spin-off with Carobot. You see, for example, DragonBot, which focuses on easy programming, all based on ROS. So these are all based on ROS-I. You can see basically Motion Robotics has been bought by Skio Automation, which is a big automation company, system integrator in Germany. And DragonBot has been bought by Keba AG. And Node Robotics is our new spin-off. I think they left last year. Well, in the beginning of this year, all the employees that went over in that spin-off have left. Basically, they focus on navigation. They provide right now, I think, 300 or 400 AGVs, plus their software in BMW plants. So also pretty successful spin-off using ROS. And then the next question for us is, okay, what do we want to do in the future with ROS? And there for us as an institute, it's very important to look into, okay, what are the big trends? So what do we need to solve in the future? And I think that's what every roboticist should be aware of. Okay, what do we need to solve in the future? For us, basically, one thing is, okay, the warehousing industry. Okay, we all know that the workers in the logistics centers, at least in Germany, are getting older, need more support, and that is where robotics can help. Similarly, in manufacturing, there has, for example, been a study from the IFR that shows, okay, basically, if you use robots in manufacturing, that correlates with employment and prosperity. Similarly, we see in Germany at least, we have pretty big housing goals. So there needs to be done a lot of construction to basically build those houses, but the problem is we don't have the workers. So the solution there is, okay, we need more automation in construction, and that could be achieved with robotics. Healthcare, I think that's in most of the countries a huge problem. Germany is not one that is better there, so basically we have a huge lack in skilled workers. So there we also need to basically see, okay, can we support that somehow with robotics? And then the third thing is basically in Europe we are looking into agriculture and trying to make agriculture more sustainable, use less weed control products, chemical weed control products. So there's also one thing that robotics could solve, mechanical weed control in the end. Yeah, so that's basically the challenges that we're seeing in front of IPA and that we are currently working on solving in the future. And now I want to go over and show you, okay, basically ROS-II is now at a point where we can use it to solve such challenges. The one big thing that we had before, or I would say even last year, is that the hardware interfaces in ROS-II weren't really that present. So basically we didn't have a lot of opportunities to really connect with hardware, which is, I think, one of the major things that you need to do if you build robots, right? You need the hardware. So I just want to give you some highlights of new drivers and hardware interfaces that have been developed in the last years. So the first of them is the universal robots driver for ROS-II. Basically, I think that is one of the big success stories that we have within the ROS-I project. So the ROS-I project was a European-funded research project where we basically funded a lot of small projects. And one of them was the ROS-I driver for the universal robot that was funded under this. And the nice thing that we see now is that UR picked up this development and they are now supporting it based on the company. And they have even built the ROS-II driver, which I think at this point is the most developed one that is on the market. So check it out. Similarly, in the ROS-I project, we as well got ABB company involved in building the ROS-II, the ROS-I driver for their robot, plus interfacing libraries, which are now used in a driver developed by Picnic Robotics for ROS-II. So also great success story, I would say. The third thing I wanted to show is basically development that we've been doing with a company called Phoenix Contact that are producing PLC devices, as well as a lot of connectors. So that's basically, I think, the part that one knows about that kind of company. But they as well have a line of pretty advanced PLC devices, so a series that they call PLC Next, which enables pretty cool stuff like running Docker containers directly on your PLC next to the ISO 61331 environment, right? So that's pretty cool, and essentially we got to working with them and building a bridge between ROS-II and their PLC devices, and basically it's now ready for early bird testing. So if you are interested in using such a thing, yeah, just contact our friend and colleague Öztürk at Phoenix Contact. So you have the contact details there. Write him a short mail that you want to test it, and he'll get into contact with you. Basically, I think this opens, yeah, quite some new possibilities in interfacing as well with hardware, and especially with automation hardware. And then the fourth thing I wanted to show is basically we are as well working on porting industrial bus systems. So the first thing that we started porting actually is the ROS-II, the CAN OpenStack to ROS-II as ROS-Industrial. Pretty important, I think, for many mobile robots, but it can also be used in industrial applications because that's one of the bus systems that we usually use in mobile robots to connect with motion controllers. And right now we have a beta version that is being published probably at the end of this week that supports a lot of features already. So the whole stack is now based on Lily core in OpenStack, which is basically maintained by the company Lily. Supports YAML configuration of the whole bus. You have a proxy driver right now, as well as a motion controller driver. You have a bunch of different operation modes that you can actually use. So if you're interested, check out the source link below. It's all there. Okay, and then we come to announcements. Last part of my presentation already. Basically, I wanted to just announce we as well have our ROS-Industrial conference this year in presence, but we call it hybrid this year because basically we will only have 60 people and we will be live streaming. So if you're interested, registration is open. Go to the link below and yeah, just register for it. So basically it's 2 days, 7 sessions of different things, around 20 speakers, and yeah, hopefully going to be a big success. One special session that I wanted to point out is we're going to have a ROS-II manipulation workshop there, for basically setting up a robot cell in ROS-II. So basically the whole process that we knew from ROS-I, doing that in ROS-II, basically starting from your cut model of the robot cell, going over description package, so your DF description, to the full move-it configuration that enables you to operate the real robot. In this case, we're going to use a UR robot, but yeah, as I said, that's probably the most advanced driver. So if you're interested, just register for the conference. And then the last thing that I wanted to point out is that we had a little bit of luck, and we have a new European research project that we're going to be working on in the next few years that will be based on ROS and will be looking into machines that understand, so basically cognitive machines. In that project, we're going to try to bring together model-driven system composition and machine learning algorithms. We're going to have 3 use cases. So on the one side, social robots, so basically robots that directly interact with people, talk with people, and so on. I think pretty interesting here. Then we have inspection drones, so use cases, for example, in the oil industry or this kind of inspection tasks where you have big infrastructure and need to inspect there. And then finally, as well, manufacturing robots that yeah, work in production and need to understand what they are actually doing. So that's great, and I hope that we're going to see a lot of nice results. All of them are going to be open source because European Union is also now pushing that all research results are going to be open source, so that's pretty nice. Yeah, and that's all. So if you have questions, just ask me, and yeah, hope to talk to you later.
Yes, so we have 5 minutes Q&A.
Thanks for the presentation, that was great. I have a question for you, but it's not about a particular slide. But we talked earlier about interoperability, and VDA 5050 is coming out of Europe, and I'm just curious if you've had any interactions with the VDA 5050 team, and if you have any sharing or lessons for the community on that.
How to say, I didn't have personally direct interaction, but maybe you've seen that our colleagues have created the VDA 5050 messages package. Basically, that's navigation people. Yeah, so VDA 5050, I think it's mainly pushed by Daimler company and is being used in their facilities effectively, but it has its shortcomings. I know of discussions with our colleagues. And I mean, there's also like other people that are trying to do similar things. I think Mars Robotics also published something in a similar direction, and I know that OPC Foundation is as well looking into something similar. So we're going to see probably a bunch of different standards on that, which is not super nice, but yeah, let's see.
ARTC. I had a similar question like Matt, so basically on OPC UA, you already answered. So, but in general, what's your take Industry 4.0 and the frameworks, especially the open frameworks for Industry 4.0 and alignment with ROS?
Okay. Generally speaking, I think Industry 4.0 is being fueled by open source solutions. So basically, open source solutions enable you to just try out things fast, right? And that's basically the driver of innovation. If you cannot try out things fast, then you're never going to do it. So that's I think what enables innovation nowadays, and specifically Industry 4.0 is like open OPC-UA standards, ROS coming into play, and a bunch of other open source solutions that we have in the market. Thank you very much.